So we've now seen primitives. We've also seen means of combination. Simple arithmetic things, expressions that we can use to compute values. I said earlier there was one last piece, abstraction. Ways of giving names to things, so I can refer to a value just by its name and reuse it. We're going to see other kinds of abstractions as we go along, but that's probably the most important first one. And so we can now introduce that into our programming language. In Python, we do an assignment using an equal sign. And you see an example of it right here. There is an assignment of a name to a value. And in particular, the value will just be computed the normal way. In this case, it's simply that float. That's what we call a variable. It's a name. And the equal sign gives us an expression called an assignment that says bind to or associate with the name pi the value 3.14159. Once we have that, we can use pi wherever we would like. So in fact, if I go over to my machine and I do the same thing, I say pi is equal to 3.14159. If I now ask for the value of pi, it prints it back out. I've bound pi to a number. I could do other things. I could give an approximation to pi, and I want to put this one up because I want to remind you that if I were to use double slash, I would get just the expression 3, but here it's going to give me something a little different. And if I do pi approx, I say 22 divided by 7, and I ask for that value, I get a little bit better, or maybe not better, representation of pi. That value is stored away in computer memory. It's in something we call a name table, where the variable pi has associated with it a value. And as we said, we can just retrieve it by asking what's the value associated with that name. Once we have that, we can start putting together more complicated expressions. So why will we give names to values of expressions? A couple of reasons. One is I want to just reuse the name and not redo the computation to get the value. If I actually had some very complicated arithmetic expression that reduced to a simple value, I don't want to redo it every time. I just want to give it the name. The second one is it can give me code that's much easier to understand. The name ought to be informative. It lets me think about what it's telling me about what this represents. And finally, it's going to be easier to change the code later if I've just got a name and I want to change the binding of the name and reuse it. So here's a simple example. I can bind pi to a value. I can give a radius, say 2.2, and then I can compute the area, pi r squared, and that'll give me a simple little computation. Those expressions also tell me something about what I'm trying to capture, and so those names turn out to be really valuable. One of the things to keep in mind is that this is simply following the sequence of steps we talked about. It's not like doing math. In programming, you do not solve for x. So for example, in this little example, I define pi to be 3.14159. I set up a radius. This is just a comment. We're going to come back to that. That hash sign says it's just something that's going to be there for me to read. The computer doesn't do anything with it. I can now compute the area. And then I can decide I want a different radius. And in fact, look at this expression here, because what it says is get the value of this expression, which is what's the value of radius? 2.2. It's the value of 1, add them together, that gives me 3.2, and change the binding so that radius is now 3.2. This does not change area. It's not like a set of mathematical expressions. It's simply following the sequence of instructions we gave it. And that means that if we want to do something different, we would need to recompute area. Again, I just want to repeat what we said because it's important. An assignment statement says, find the value on the right-hand side of the expression, take the name on the left, and assign that name that value. One last thing, we're going to see a lot of shorthand here. That expression, adding 1 to something, it's something we're going to do a lot. It's called incrementing. And so there's a shorthand, which is you could write this instead as just plus equals. And that is simply short for saying radius plus equals 1 is radius equals radius incremented by 1. The last piece here is you saw we could change the bindings. I can rebind a variable name in a new assignment statement. The previous value may still be around in memory, but it's lost. There's no handle, no way to get to it. And as we just saw, the value for area doesn't change until you tell the computer to do the calculation again. Another way of thinking about it is, if this cloud is my memory, when I do a binding for pi, it associates the name pi with a value off in memory. When I do radius, I get the same thing. When I compute area, it looks up radius, squares it, multiplies it by pi, and then associates the name area with that value in memory. And now, if I change radius, it loses that first association and creates a new one. But area hasn't changed. If I wanted to recompute the area for this circle, I would need to do another call to area to make it happen.